Hello everyone, and thank you for joining us today. We are a step ahead, and today we're running our data science, statistics, and machine learning workshop. So just for a little introduction, we're a step ahead, and we teach workshops and lessons on coding, robotics, and web design. Our sessions are free and completely open to anyone, and we will hand out a form to get a copy for you guys to get a copy of the slides at the end. But it is still good idea to take notes if you want, and if you have any questions, you can feel free to unmute or type them in the chat whenever you feel like. And today we are partnered with Team Coda Dragons, which is a first tech challenge robotics team in Santa Clara, California. Coda Dragons is a 10-member student team who work to build and program a robot that then participates in a robot game with 3 other robots. So we are part of an organization called FIRST, and FIRST stands for Inspiration and Recognition of Science and Technology. And FIRST is a huge encourager of strong core values and being a good team player. And something that they especially highlight is gracious professionalism, which is being able to embody some of the main core values that they support, all while being professional, even when not on the field. So this is last year's World Championship for FIRST. We just thought we would show you the video in case any of you are interested in going into robotics. Yeah, so the robots actually come out being very cool and being able to do a lot, but it is also a lot of time, a lot of passion, and a lot of commitment. So it's just something to look into. I know most of you are grade 6+, so you can start participating in FTC starting 7th grade. So yeah, it's definitely something to look into. And FIRST also offers FIRST Lego League for children who may not qualify for FTC yet. So there's a lot of opportunities to get involved in robotics if you are interested. So thank you. All right, now let's get to today's workshop on data science. So before we get started, does anyone know what data is? You can either type it in the chat or unmute. Exactly, data is information. That's perfect. Does anyone else have anything you want to share? No worries if not. Information about a certain topic. Yes, exactly. Very good. So this is exactly what data is. Data is basically just some sort of information that we're storing, and it can be basically anything. If you think about anything in your life, basically everything, we're surrounded by data, and it gives us so many benefits. One of which is actually data science. Okay, so this is a little bit, I know this is a little bit out of place as of now, but we will connect into data science. So I know it's written here, but does anyone, I'm sure we all do know, but a library is basically a collection of books. Does anyone else know what else a library might be other than a collection of books? Like, what are some things you think about when you think of a library, other than like the quiet environment? And this, what sort of stuff does a library have, I guess you can say? Okay, I think that's fine. We can move on and then we can come back. But a library, as we all know it, is a collection of books. And these books are more often than not written by others. So there's an author, and you can go and read their book at a library, and you can even check out the library to take to your home. And a library and programming works very similarly. So it's a collection of programs that were already written by someone else. So instead of you having to create your own programs, they create some starting lines that you can then add upon. So similar to how you can take a library book home, you can import these libraries into your program. And this is very, very important for things such as data analysis and data science, because there's so much data being involved and there's so many algorithms, and you don't want to have to start programming that from the beginning. You can use already created libraries. One of the very popular ones for data science is pandas. And this will make your job a lot easier, and it will be much easier to do your programming in data science. And some of the content that they were covering in the video is also something that you'll see in machine learning, which we will cover a little bit more in this workshop. But that's just something to think about as well. So pandas is not only useful just for data science, but it can also be extended into other similar fields as well. All right. So what is data science? What steps are even involved in data science? You guys are probably all wondering that. So here's a little breakdown of it. The
the first thing you have to do in data science when you're working with real world data, and we're talking about, like, for example, we see a problem around us where users are canceling Netflix subscriptions. So the first step is to obviously define the problem. So what is the problem you're trying to solve using the data? So in this case, the problem is that users are canceling Netflix subscriptions. And the second thing we need to do is data collection. So I'll give you guys all a minute. Do you guys have any ideas as to, if we were to fix this problem, if we were to find out what is the cause of this problem, what kind of data would we need and where would we get it from? You guys can put it in the chat or unmute.
And something to also think about is, what sort of questions would you ask?
Hello.
Hello, we're just getting started. So we're doing an activity right now in which we're trying to become data scientists ourselves and solve a problem by using data. So the problem is that users are canceling Netflix subscriptions. What are some of the questions you would ask them, or some of the information that you would want to get from them? And I see Adia put in the chat other possible competitors. That's a very good option.
Yes. All right, yeah, so like Adia said, other possible competitors. Yes, Divya, you're absolutely right. The problem is that users are unsatisfied with Netflix or have better options. Perfect, yes.
So something that we thought of for this is that we can ask them questions. So we know that the problem is that people are not happy with Netflix. And so we were thinking about, what sort of questions can we ask them knowing that? So what are some questions that you would want to ask users? Like, you would want to ask them, for example, I'm seeing in the chat a lot of, why did they choose not to, or why are they choosing to leave Netflix? So we can actually get a lot more specific than that as well if we're trying to find the real problem. So it's just as if, like, you would ask someone a specific question when trying to find a solution. Some of the questions you can ask is that, what sort of shows are people watching in other places that we're not offering? Or what do users, I don't know, something like maybe what do they like to eat while watching? You don't really know. It can be a various amount of things, and you can always, so asking the customers is definitely the big thing. And I'm also seeing,
we can gather data from feedback from users. Yes, absolutely. Putting users, asking customers. Yes, all of these are absolutely correct.
So let's say we collect 5 pieces of data. So for example, what shows are they watching on other platforms compared to Netflix? What their favorite pet is? What their favorite color is? What platforms they're preferring over other than Netflix? We can ask them a variety of questions, and some of them might be directly influencing their choice. Some of them might be, Netflix has really bad, it loads a lot, so that's why I'm not using it. And some of them, they might be like not very related. Like, my favorite color is white. Like, there's a very low chance that that's one of the reasons that they're canceling their subscriptions. So it's important that we clean up this data, which is basically removing all of this unnecessary information.
All right, so next we have to analyze data. So after we have our data set that we want to analyze, we have to look at the data and see, well, what are the patterns? Why are people solving Netflix? Why are people quitting Netflix? So for example, if we see that, let's say we see that 75% of the users are watching mystery movies, but only 5% are watching something else. Like maybe only 5% are watching like horror movies. But let's say that Netflix only has one mystery movie, but 75% of people are watching mystery movies. We can use that kind of analysis to find the gaps and to find basically where the problem is. So in this case, it's that the 75% of the users want mystery movies, and Netflix isn't able to give those because it only has one. So that's a form of data analysis.
And now we're doing a data modeling, which is basically making a solution. What do you think can be a solution to a low amount of mystery movies compared to the high amount of people who want to watch it?
I'll put the problem in the chat so that you guys can.
And mystery movies, yeah, it's a good option.
Perfect.
Definitely.
Yes.
There's also a few other things that we can do to make their Netflix experience better. So let's just say for some reason everyone's saying that their favorite color is turquoise, and there's basically no turquoise on Netflix. There's those little things that we can change as well. But the main problem here is that there are very low mystery movies, so that would probably be what we want to target the most. So we're looking at what percent of the people have the problem. So if the highest percent of people are having this problem, so we're going to start by solving that first. And then we can go down the list and solve the other things as well.
All right, so the next part is data validation. So which basically, so far, we've identified the problem, we've analyzed the problem, and we've come up with our solution. And now we need to actually see whether the solution works. And the only way to see that is actually to test it and to, let's say our solution is to add more mystery movies, like Divya said. So we need to actually add more mystery movies and see if that improves anything. And it often takes multiple tries. These are called iterations. So, you change something and then you see how well it works. And if it doesn't work as well, then you change something else. You have to keep going through it a couple of times before you get the perfect solution.
And that's what sometimes the data can't tell us the whole story. So we know that we should add mystery movies, but what if there's a particular actor that people are liking, or there's someone that people are not liking? So we need to continue to make those iterations, looking at the data and about what people are enjoying in order to make the best results.
All right. And the final step is deployment and optimization. So we need to get the word out. So now that we have more mystery movies on Netflix, if we don't tell anyone, then it's probably not going to improve, the Netflix subscriptions. So, we need to tell people that their favorite mystery movies are coming onto Netflix. And so then they might, maybe remove their not unsubscribe, and maybe they'll come back to being Netflix subscribers. And for reference, these are basically what we covered in terms of the problem, the data collection, cleaning, analysis, modeling, validation, and deployment of the solution.
If you guys would like a copy of the slides, we will send them to you at the end of the workshop. So there's no need to take frantic notes. All right, so now let's talk about what is statistics. I'm sure all of you have heard of it before, even if you don't know exactly all the terms, but just let us know what you think statistics is. And it's very similar to data and data science, so there is going to be a little bit of an overlap.
Yes, exactly. Showing data and graphs. That's very good. All right, we can go a little bit deep into this too. So, yes, exactly, Divya. I see. Yes, inferences, exactly, Kabaish. Yes, inferences. Basically, you do make inferences from the data using statistics. Very good. And through statistics, we can find trends in the data. Exactly, very good. So just for some basic definitions, today we'll just give you kind of a basic introduction to statistics because it is kind of intertwined with data science. So statistics is the study of number-based data sets. So if you have a data set that has a lot of numbers, then you want to use statistics, like everyone said in the chat, to find trends and to make inferences about the data. And a data set, as you guys discussed basically about data before, it's a set of information about a particular topic. And statistically significant, this is a bit complicated, but it's basically an outcome that is too apparent to have been caused by chance. So if we look at the previous example, for example, we said that 75% of people on Netflix want mystery movies, but there's only one mystery movie. Now, if it was a little bit different, if it was, 75% want mystery movies and there are 1,000 mystery movies, then we can tell that that's not really significant. There's not really much of a connection there. We can see that, that's probably not the reason why they're quitting. So that variable is not statistically significant. Whereas if 75% want mystery movies and there's only one mystery movie, then we know that that's probably the cause of it. So that is statistically significant. And so that is a bit of a difficult concept. So don't worry too much if you didn't get it fully. And the average is kind of like the center of a data set if you organize everything chronologically. So basically, if you have 10 numbers, it's kind of like right in the middle, where the middle number is. And a graph is basically just a visual way of representing data. There are a bunch of different types of graphs, but it's just a way of seeing your data instead of just writing down all the numbers. You see it in a cool shape or just see how the data is spread.
And I think some of you guys are talking in the chat about finding trends in the data. It's very hard to just look at 50 numbers and be like, oh, what is this saying? But if it was in the form of a graph, or it was in the form of a bar chart or something, it's so much easier to understand what we're trying to see. And that's something that data science does as well. It kind of helps you analyze that. So next we're going to be going a little bit into machine learning and about what exactly it is. And a little bit, just to know, especially in the programming world, machine learning is often written as ML just for the ease of talking. So if you do hear people saying ML, they're generally referring to machine learning.
Okay, so like Sahiti said, machine learning is also called ML. And so if you break the word machine learning, or the phrase machine learning down, see that machine is an object that helps humans, and learning is basically understanding something. So machine learning is basically when a non-human object, in this case a computer, is learning or understanding something. So you can kind of treat it like the machine is a student and you, the programmer, is a teacher. So for example, as a kid, you guys are probably trained to identify the following shapes. So you were probably showed this and taught this is a square. And then you were shown this shape and taught this is a circle. And then you were shown this and you were taught this is a triangle. And you're probably taught this hundreds of times. People probably kept telling this stuff to you. And eventually, the next time you came across this shape, because of all the previous knowledge you had, because of all the knowledge that everyone gave you about shapes, you were able to identify that this is a circle. You were basically trained using the data that they gave you. And this is basically what happens in machine learning. So the computer is trained to recognize different types of data. And this data can be objects, shapes, sounds, images, basically whatever you want. And it uses AI. AI is artificial intelligence, which we'll cover in the next slide, to apply that knowledge to the real world. And so machine learning obviously uses a lot of data. So if you look at the example above, you'll see we have different shapes, and each of those shapes is, unique. And you probably, if you want to teach a kid, how to distinguish, how to differentiate between the different shapes, you probably need to, show them a lot of different shapes. Probably need to show them like hundreds of each type of shape so that they understand it fully. And so that's kind of the same thing here. Machine learning, you need a lot of this kind of data in order to be able to run machine learning. And the types of things that the machine learning is trained to recognize are called classes. So for example, the classes are kind of like categories. So if in the shapes example, we have 3 categories or classes, and they are square, circle, and triangle. So the same way in real life, the kind of categories or the different things that the machine learning algorithm is trained to recognize are called classes.
And just really quick, something that you might have noticed is how do you differentiate a square from a circle from a triangle? Can you guys put in the chat, like, what's something that's in this circle that helps you identify that, oh, I know what this shape is? So something that's unique to only the circle. Circle is round with no sides. Yes, that's true. Circle has no sides. So that's the exact same thing the machine needs to do. So if you show a circle, square, and triangle, like it starts looking at those patterns. So you guys basically just found a pattern that every time it's always triangle has 3 sides, square has 4. So we're looking at those different things that are helping us differentiate. And that's the same thing that the machine needs to do. So it needs to see it so many times to understand, oh, I finally get it. This is a pattern that between all circles, there's never a side. So that's also what you guys did as you were kids when you were learning this. So yeah, it's a machine doing the same thing that you did, just faster and more efficient often.
Okay, so the next thing we're going to be covering is artificial intelligence. And now this is kind of similar to machine learning, so don't worry too much if you get confused and you don't know which one is which. But basically, machine learning is a part of artificial intelligence. So artificial intelligence is like a really big thing, and machine learning is part of it. And so machine learning, like we discussed, it uses data to learn and improve its accuracy, because the more data you give machine learning, the better, the more accurate it becomes. If I were to show you 2 shapes right now, you wouldn't be super good at differentiating shapes. But if I were to show you 100 different shapes and keep training you, then you'd become a lot better. So just the more data and the more training I give you, the better you become. And so that's kind of the same thing with machine learning. And so AI uses machine learning to function. So basically, what we're trying to get at here is if the machine is trying to understand that this is blue, this is purple, and this is red, is this machine learning or artificial intelligence? So the answer to that is basically that in the learning stage, you can kind of call it machine learning because it's learning. And then artificial intelligence is the stage where it's kind of using that intelligence, everything that it's learned. So in the stage where it's trying to learn, this is blue, this is purple, this is red, that's machine learning because the machine is learning. And then in the phase where it's not learning anymore, but it's like performing all the tasks. So it looks around and says, this is purple. Then that's artificial intelligence because it's using all the data and it's using all of its knowledge.
And something I think about here is also like when you were learning addition as a kid, your teachers or your parents or someone probably taught you like how to do addition. Like they probably gave you some example problems. They probably showed you how they do it. That's all you're learning. And then your actual using of this, so that would all be the machine learning. And actually using this, like actually going and like taking a math test and having to figure out what 2 plus 3 is, that's kind of what we kind of call more artificial intelligence, or what's some part of artificial intelligence that you won't find in machine learning.
Yes. And AI and ML are actually used very, very frequently in the real world, more often than people think they are. So for example, if we take YouTube, I'm sure most of you have watched YouTube before. And you've probably noticed that YouTube doesn't just put random videos on your feed. So when you open YouTube, you get like a bunch of video suggestions. And these aren't completely random. They're kind of similar to the ones you previously watched. So how does YouTube know what videos to recommend you? So the thing is that every time you watch a video on YouTube, YouTube takes that data and it trains its machine learning and AI algorithms. And so it uses that data to find other similar videos that you might like.
And coming back to the data thing, like we're again back to data science. So you can see that they're all very intertwined. So they need to collect statistics, which it uses for data, which it then uses for data science, and then you're seeing that being used here. So they're all very connected topics, and I would say like the seed of it is the data and the statistics, and then the outcome is more of what you see when it's recommending you in artificial intelligence and machine learning. So now you're going to try to create your own machine learning algorithm. So many of you have probably used Teachable Machine with Google before, and if you haven't, then today's your lucky day. So we're going to be helping you create your own model. And so you can do this by either taking pictures from the internet, just taking pictures of yourself, however you'd like to do this. So for example, some of the project ideas that you can do using Teachable Machine are identifying cats versus dogs, detecting different shapes, like you saw on the previous slide, recognizing different colors, detecting masks or no masks, emotion detection, like happy, sad, person detection. You can do basically anything that you would like. And for the sake of today, we won't actually be programming these, but we'll be using this website called teachablemachinewithgoogle.com. So on this website, it's very easy to simply train a model and then use it for your sake. So we can be putting the link in the chat right now, and then you guys can go ahead and explore with it. If you have any questions or need any help, let us know. We're here to help you. And so we'll give you some time to go ahead and try this out.
If anyone has any cool ideas for what they want to do for their machine learning project, feel free to put them in the chat. So you guys can play around with this for a bit. We'll leave the instructions up.
And if you want to share what you've made, then do let us know, and we'll feel free to let you guys share your screens as
well. While you guys are working, we can also share our screen and show you one of ours too, so just so that you guys can understand. Like we said, classes are basically the different things it's trained to recognize. So we are going to do something a little bit fun today. So for ours, you guys can do whatever project you guys want to do, but we're going to do pig versus peacock. So we'll call this pig, and we'll call this peacock. So basically, these are the two things that the machine learning algorithm is going to be trained to recognize. And if you want to add, to add the data, you can actually do it two ways. You can either use a webcam, or you can either upload data basically, where you just add files. So if you have any like downloads or anything, or you can actually like take pictures like this using your webcam. So we're going to use that option right now.
And just for reference, we're on the image training for now. And if you guys do want to go ahead and try out the other ones, feel free. But we're going to be using the image one for today. So, like for example, this was their piggy. We can take. So we'll do multiple pictures.
You want to get as much data as you can, because like we said, the more data, the more accurate your machine learning model will be. So we're just gonna keep clicking some pictures. All right, so we've gotten all the pictures that we want for the pig. We got 42 images, or 41. So then we'll try something similar for the peacock. So try to get just as many images for the peacock as well. All right. Then if we click train model, it's going to prepare the data and train the model for you. So that's going to take some time. All right, so now, if we were to put in, let me turn the input on. So right, so now it's able to detect. When we put the peacock there, it's able to detect this is 100% peacock.
When we put the pig in, starting to lean towards pig.
Yeah.
And when we take them both out, it's going towards peacock. So what we're understanding from this is that it is kind of biased towards peacock, because even when there's neither peacock or a pig in the screen, it's just looking at the background or something is making it decide that peacock is the right solution. So that's kind of something to also think about, not just about when it's peacock or when it's pig, but also like if I was to take a donkey and put it, would it still recognize it as a peacock or would it take it as a pig? Those are all things to take into account when making the models.
Yes.
So now that we've showed you guys an example, you guys can continue working on yours and just let us know when you're ready or when you would like to share.
Yeah. And you guys can feel free to let us know whenever, if you guys, how much more time you need or if you need any more time at all.
Mm-hmm.
You can let us know in the chat or unmute. All right, if you guys need any help or need any more time, you can feel free to let us know in the chat or unmute.
If not, we'll give time around until 7:05 and then we can.
Sounds good. We'll leave you guys around 10 minutes.
Or David, do you want to share your model?
Yeah, sure.
Yes. So you can go first and then Ade can go after you.
Okay, yeah. You guys can share your screen if you want. I'll stop presenting.
Okay. Can you see my screen?
Yeah.
Yeah, I basically did dogs and cats, and I did 20 images for each of them.
Nice.
And I put in an image of a cat, and it showed up as a cat.
Nice. Very good.
But yeah.
That's good. Good job.
Yeah.
And Ade, do you want to share? You can just explain it too if you would like.
Yeah, you can present however you want. If you want to just explain it or if you want to share your screen, anything's okay with us. If anyone else is done, you guys can put it in the chat or share. Okay, no worries.
Oh, okay, yeah.
No worries, Satya. Nice banana and flower.
Yeah.
Good job.
Did you take inputs from did you use your camera or did you take them from the internet? Oh, okay, that's good. So then I guess we can move on for now.
Yeah.
But if you guys do need any help, feel free to stay after the session as well. We're more than happy to help out.
All right, let me share our final slides.
Okay, so thank you all for coming today. If you'd like to get a copy of these slides or you would like to get feedback, feel free to send all that to tinyurl.com/mx6vh414. We can put that link in the chat in just a moment. To contact us, you can go to siliconvalley.astepahead@gmail.com. Website is siliconvalley.astep.com/astep.step.ahead. You can also find our Instagram and YouTube here. In addition, if you want to learn more about robotics, about FIRST, Kodo Dragons, anything relating to that, then you can also email kododragonsftc@gmail.com. We can put all of those links in the chat. So yeah, you can start with the feedback when you're at the end. I can get the emails.
Oh, good, yeah, nice. The tiger is 49% cat and 51% dog. That's interesting. So the model's not too biased, actually.
Mm-hmm. But actually, I would say tiger's actually more cat.
Yeah.
So I mean, maybe it just needs a little bit more variation. But yeah, that's pretty good actually.
That's pretty good.
It's not like looking at wrong features.
Yeah. So I will put the link in the chat for anyone who wants to get a copy of the slides. And yeah, so other than that, that's all we have for you guys today. Thank you so much for coming.
We just put the link to the FTC email, the robotics emails. If you have any questions, concerns, or would just like to join the subscription list for that as well, you can feel free to email to that email.
Yeah, so put the email and the link in the chat. So feel free to take a look at those.
And once you guys get your models working and have filled out the form, you can feel free to leave. Thank you so much for joining us today.
Thank you.
And we look forward to seeing you in more sessions. Thank you.
Bye. Thank you.
Bye. Thank you.